Good afternoon. My name is Jose Antonio Lazaro, and I'm going to talk about my evidence too. That is about a model of suspension system. Okay, first I will talk about the program that was developed in the second delivery by our team. The program we designed was created to analyze and express dynamic variables that act on a semi-active suspension. Among the main features is that they have two output variables, which are the acceleration and the displacement of the chassis. Based on the given data, I'm going to check the good performance of the program we developed. To check its good operation, I will apply a disturbance on the road. Okay. So here we have the simulation that helps us to do the analysis. Okay. Here we got a graph of position that the program gives us. So we can observe the position graph that indicates the displacement of the chassis when the bomb is detected. Once it detects the shock, the shock absorber is activated and remains stable for a range of time, in which we can see the position is constant. So this factor, we can see it in this graph. So here we have the graph of acceleration. This graph simulates the change in the speed that appears when the disturbance is detected. We can see a peak, but then the peak drops and shows it also remains constant for a range of time. This happens when the shock absorber absorbs the impact energy. To explain the representation of our model, I base on the state space. Previously, a physical analysis was performed with the help of Newton's second law to obtain the equations. Once we obtained it, the inputs values were defined, which is the road. The output also was defined, and it is the position of the chassis, and the variables are the velocity and the position of the mass. After we define this, the values are introduced as state vectors. So here we can see the state space that help us to analyze the system. So now I'm going to talk about the advantages and disadvantages of a simulator. The main advantages of a simulator is that it allows you to analyze the basic components of the system without having to do it physically. However, I think that in many cases, the simulations are not always very accurate and do not consider certain factors that affect physically, so the results are different in comparison. About how we work and where were my contributions for this work, sorry. In a few words, in my team, the contribution was equal. My main contribution in the group work was in the physical analysis of the active suspension system, applying the laws of physics as Newton's second law to do the equations that help us to do the analysis. And I also draw the free body diagrams to do a better analysis. So in conclusion, I saw that through the course I managed to develop and apply the knowledge of physics and modeling in complex systems as a suspension. In addition, I also analyze and understand dynamic systems and also applying them in a very useful tool such as Simulink that help me to understand and do it in an easier way. That's all. Thank you for all.